Alright, so in this video, we're going to be focusing on what is called the least common multiple and the greatest common factor. And these are things that we're going to be just finding right now just to practice, but then really the goal of this is going to be to use this to do something called equivalent fractions, right? Simplifying fractions and changing the way fractions look. Okay, so let's start off with least common multiple. So the phrase least common multiple itself, we can kind of break down, and you'll see that the definition really just comes from these three words. The word least means smallest, right? So the word common means something that a group of lists share, something that a group of items share, right? And now let's talk about this word multiple. This is really the kind of the vocabulary word here. And what does multiple mean? Well, what multiple means is that if I generate lists of multiplication tables for two numbers, we're going to find that those are what multiples are. So I'm going to do a simpler one than 12 and 18, and then we'll talk about 12 and 18. So I'm going to start off with just something like 2 and 3. Okay. So in order to create the multiples of 2, what I'm really going to be doing is saying, let's do 2 times 1, and then we're going to do times 2, and we're going to do times 3, and we're going to keep doing this list. All right. And I'm going to do the same thing with 3. I'm going to say 3 times 1, 3 times 2, 3 times 3, and I'm going to keep going. Okay. So if in this case, 2 times 1, that's 2. Okay. 2 times 2 is 4, 2 times 3 is 6, right? And I keep going, 2 times 4, 2 times 5, and we could go forever, right? The list of multiples of 2 goes on forever. It's infinite, but we're going to stop at 10, right? Because we don't care about all of the multiples. We actually just care about the smallest shared multiple, right? That's what least common multiple means. So 3 times 1 is 3, okay? 3 times 2 is 6. 3 times 3 is 9. I'm not going to go any further on this list because guess what? I just found the least common multiple. 6 shows up on the multiples of 2 list, and 6 also shows up on the multiples of 3 list, right? Not only do they both show up, but that's the smallest number that shows up on both lists. It is the least common multiple. It is the smallest shared multiplication number. Okay? So here's one thing I want to point out, and then we're going to talk about 12 and 18. So one of the really important things I see a lot of people do is say, oh, look, 2 and 3 are the numbers that we're trying to find, and the answer is just when I multiply together 2 and 3, I get 6. So all the time, I can just multiply 2 and 3. That will always give you a common multiple, but it will not always give you the least common multiple. And that's something you got to be careful about, is that sometimes it will work that the least common multiple is just 2 and 3 multiplied together, but that's not always going to be the case. In fact, for our next example, 12 and 18, if I multiply together 12 and 18, I get some number in the hundreds, but the least common multiple is not something in the hundreds. It's much smaller than that. So let's actually look at this one. And I'm going to show you 2 ways to do this problem, and one of them is kind of a more straightforward way, and another one's kind of a little trick to help you out with some of the larger ones. So 12 and 18, I'm going to make a list of the multiples of 12. I'm going to say 12 times 1, 12 times 2, 12 times 3, 12 times 4, right? 12 times 5. That's as far as I'm going to go because I only want to find the smallest one. I don't want to create more work for myself. Well, 18 times 1 is 18. 18 times 2 is 36. And I'm going to stop there because I just found my list, or my common multiple on these lists. Right? There's 36. There's 36. And so my answer is 36. 36 is the smallest number that is a multiple of 12 and a multiple of 18, right? Showing up on both lists. Okay. So let's say we're working with numbers that are not as nice as 12 and 18, and we want a different way. There's something called factor trees that we can use. And here's what a factor tree is. I'm going to start with the number 12, okay, and I'm going to make a factor tree. If I do this, I'm going to say, what numbers multiply to 12? And you can answer this however you want. I'm just going to say 3 and 4. You could also do 6 and 2 if you wanted. And then I'm going to keep breaking this one down. I'm going to say I can't break down 3 anymore. That's a prime number. Okay, but I can break down 4 into 2 and 2. Okay, and these don't break down either, so I'm going to stop. So this is called the factor tree of 12. Okay? And I can do the same thing with 18. And I'm going to say, here's the factor tree of 18. I'm going to break this down into 6 times 3. Okay? And I'm done with 3. Okay? And then I can break down this 6 into a 3 and a 2. Okay? And these are also done. I can't go any further than 3 and 2. They are prime numbers. So once we have the factor tree, this is kind of where things get confusing. So I'm going to do the best I can to explain this. What we're really going to do is we're going to gather up all of the unique factors, but every single time I gather something in the first list, I'm going to get rid of a matching one in the second list. So let me show you what I mean. So I'm going to say this 3 right here, okay, I'm going to keep. Okay, so I'm going to say, let's keep this one. Okay. But because there's a matching one over here, and I can take either of them, I'm just going to get rid of this one. I'm going to get rid of a matching one in the other list. And then I'm going to move on. I'm going to say I'm going to keep this 2. I'm going to get rid of a matching one in the other list. Okay, and then I'm going to keep this 2. I don't have a matching one in the other list, right? So I'm going to say that one's going to stick around. So I kept the 3, the 2, the 2, and I'm also going to keep this 3 because I had nothing in the first tree to cancel out that 3, right? So I only got rid of the 1. What I'm going to do now is I'm going to gather up all of these things that I kept, and I'm going to multiply them together. This is 3 times 2, that's 6, times 2, that's 12, times 3, 12 times 3 is 36, right? So if I gather up all of the, what I call is the unique factors in the factor tree, that's always going to give you the least common multiple. So again, I know that that's not all that straightforward, but you're going to see in the next problem it's actually pretty important to do that because if 6, 9, and 5, I'll just let you know that the least common multiple of 6, 9, and 5 is 180. Okay? So if I were to make lists of 6, 9, and 5, I would have to go 5, 10, 15, 20, 25, 30, 35, 40, and go all the way up to 180 and do the same thing with 6 and the same thing with 9. That's going to take me a long time, right? 6, 9, and 5, their first common factor is way down the list, and I don't want to necessarily have to make all of those lists. So what I'm going to actually do is make factor trees for these. I'm going to say 6, well, that breaks down into 3 times 2. Okay, 9, well, that breaks down into 3 times 3. And 5, well, that really doesn't break down, just 5 and 1, right? So I'm just going to, I'll break it down, but we didn't need to. All right, and I'm going to go through and I'm going to get all of the unique factors. So I'm going to say in this case, this 3 is going to stick around, but that means I'm going to get rid of that 3 there. 5 didn't have a 3, but if it did, I would get rid of that one too. Okay, so we're only going to keep one unique factor, right, as we move along. This 2, I'm looking along here, I don't see anything unique, right? There's no other 2s to get rid of. Okay, this 3 I'm going to keep, right? This one we got rid of when we picked up that one, and I'm going to keep going to the right, and I don't see any other 3s to get rid of. This 5 and the 1 are both unique, right? So that's this 3 right here was the only one that we got rid of because we had another one over in that list, right? So now if I multiply these together, well, this is 6 times 3. Well, 6 times 3 is 18, okay? And then times 5. Let's just come over here and do 18 times 5. Okay, that's 0, carry a 4, 90, okay? So the least common multiple of 6, 9, and 5, I said 180, was 90, right? So we can go through those lists and generate them, and that's the smallest one that we're going to get. So that's a lot quicker. Okay? Our answer here is 90, not the 180 I said a minute ago. Okay, and the way we did that was a lot simpler than having to generate the multiples of 6 all the way down to 180 and generate the list of 9 all the way down to 180. To 90, and 5 all the way down to 90. So that was a little bit quicker and a little bit more straightforward. Okay, so again, this is a method that you kind of have to learn rules for, which is not the best thing in the world to do, but it's a way that you can kind of quickly get some of those more complicated ones. So you have 2 options: make the lists and find the multiples, or if you're comfortable using factor trees, you can use that as well. Okay, so that's least common multiple. We're going to talk about one more thing, comparing numbers, and that's called the greatest common factor. Okay. So let's break this down real quick. This one's a lot more straightforward. So the greatest common factor of 2 numbers, okay, so again, I'm going to break down greatest common factor. Greatest means the largest one. Common is still a shared number, so it's got to be a number that shows up in both lists. Okay, and now let's talk about the word factor. Okay, the word factor is, the definition of factor is a number that's a part of a multiplication problem. Okay, so for example, if I said 7 times 3 equals 21, I would say that, let me fix that, 7 times 3 is 21. I would say 7 and 3 are factors in this problem, and they are factors of 21 because they multiply together and give you 21. Right? So when I'm basically saying, let's take 36 and 20 in our example here, and let's list out all of the pairs of numbers that will multiply and give you 36. Let's find all of the numbers that multiply together and give you 20, and then we are going to find the greatest number that is common to both lists. Right? So let's do this example, okay, and then we'll be done. So 36, hey, we're going to say is 1 in 36, obviously. Okay, 2 times 18, 3 times 12, 4 times 9, and then I don't have space, so I'm going to put it over here, 6 times 6. Right? So these are all of the lists of the list of all of the numbers that are a part of a multiplication problem that result in 36. Okay, so I'm going to do the same thing with 20. Okay, so I'll do that one over here just to give us some space. 1 and 20. Okay, 2 and 10. 3 is not a factor. 4 and 5. Right, and that's it. That's all I got. Okay, so I'm going to look at these two lists and I'm going to say, what is the largest number that is showing up in both lists? So I'm going to start off with the big one. So 20 not showing up over here. 10 not showing up over here. 5 not showing up over here. 4. There we go. There's a 4 there. There's a 4 there. 4 is the greatest number that is showing up on both lists. Okay, so let's do this last example, and then we'll be finished, okay, with least common multiple and greatest common factor. So 80, much larger number, so we got to make sure we get all the numbers. So I usually just start by counting. 1 does go into it because that goes into everything that goes with 80. 2 does go into it because it's an even number, right? That's 40. 3 we're going to have to check, so we'll come over here and do 3 into 80. Okay, 3 goes into 8 twice, okay, and that leaves 3 times 2 is 6. 3 doesn't go into 20, so I'm going to have some kind of remainder, so 3 is not a factor. 4 is a factor. 4 goes into 80 20 times. 5 is a factor, any number that ends in 0 or 5, right? So I can say 5, and I believe it's 16. No, 5, and let's do it, right? If I'm not sure, I'm just going to come over here and do it. Okay, this goes in once. Yeah, it is 16. So that's going to be 1 into 5, right? That's 30. Yeah, so 16. Okay, and that will give me a 30. So again, if you're unsure, I'm not going to, take a guess. I'm going to just keep going. Right, 6. Let's see if 6 goes in. So this is going to take some work. These are much larger numbers now. So I'm going to say 6 goes into 80 once. 1 times 6. And then again, I got a 20 when I bring it down. 6 does not go into 20. That is not a factor. Right? 7 is not. 8 is, right? Because 8 times 10. Okay. 9 does not. Okay. And then 10 I already have on the list, so I'm finished. So that's as far as I got to go. So that one, again, the hard part here, hopefully, is going to be, once we get to these larger numbers, finding that all of the numbers that are factors. Okay, so 48. Okay, here's my list of 48s. 48 and 1. Okay, let me actually fix that. We're going to stay consistent here. Okay, so we'll say 1 and 48. 2 and 24. 3 does go in. It goes in 16 times. Okay, 4 goes in 12 times. 5 does not, because this does not end in a 0 or 5. 6 does. It goes in 8 times. 7 does not. And then my next number on the list is 8, and I've already listed that, and that's how I know I can stop. Okay, so these are the lists of all the factors of 80 and 48. So what I'm going to do is look at these lists, start with the biggest one, and see what's on both lists. So 80 is not over here. Okay, 48, not over here. Okay, 40 is not in the red list. 24. All right, I'm just kind of going down and looking at the largest numbers I can see. 20 shows up here. 20 is not in the list of 48s. 16, there we go. There's a 16 here, and there's a 16 here. That is the greatest number that is shared by both lists. That is our greatest common factor.